mind is that when you go through the process of estimating the effort and duration, and you ask people how long something's going to take, typically when they tell you, they're saying that's how long it would take them, right? And the more junior people are going to tend to defer to the more experienced people in that process. So there's a risk that you will embed an assumption into your estimate, which is the most qualified person is always the person doing the task. And that's typically not true. So you have to, as you go through the resource assignment, you have to look at, is this the most qualified person on the team? If not, do we need to revisit the estimated effort and duration? Also, you need to ask the question, if nobody on your team is particularly qualified to do a particular task, then how good can that estimate be to begin with? Because the estimate was based on a certain amount of expertise. So if you find you're in that situation, then that's yet another project risk of we really don't know how long this is going to take. Okay, so for test environments, we've got hardware, software, networking, facilities, all of this other stuff that we need to get the job done. And certainly you want to make sure that any expensive or long lead time types of items are properly assigned. It's one thing to discover that you didn't estimate the right number of pens on the project. That's probably a recoverable estimation error. If it turns out that you need a $500,000 server, yeah, that could be something you might want to think of up front. It can cause some problems later if you discover that midway through. And then things like test tools, testware, test cases, test data. Are you going to create your own? Can you reuse stuff you've already done from previous projects, or do you have to create it new? You're going to use commercial off-the-shelf tools. What are the pricing issues associated with that? What tools do you need, and so forth. So you want to think through these things. Now, some classic mistakes, 3 classic mistakes that people make here when they're doing this at this step of the estimation. One is assuming that 2 people can get the job done in half the time. So if I just double the number of people assigned to some particular activity and cut that duration in half. This is so famous that there's a book named after it. It's called The Mythical Man-Month by Fred Brooks, which if you've not read it is worth a read. But basically, software engineering work, testing included, is the mental activity, right? It's thinking work. And you can't, it's not like shoveling sand or something, where the more shovels with people on the shovels you put around the pile of sand, the faster the pile goes down. Be careful not to overload the tools of the test environments. That will have a tendency to produce a very high rate of false positives, failures that are actually just natural consequences of having too many people trying to use this tool at once, or too many people trying to use an environment at once. So try to avoid doing that. Don't build that into your estimate. And then make sure that your setup and support tasks for the environments and the tools are built into your estimate as well. That's another easy thing to forget. But somebody's going to have to keep the environments up and running. He's going to have to install the tools potentially and so forth. Okay, so with that done, we now see that the schedule has transformed into more of what we would expect. End date of April 30th, we see the resources here hanging off the end, and then the dependencies shown as the arrows in between. So that now looks normal. So we've got this realistic, actionable schedule, but then, management looks at that and says, no, that's not okay. April 30th, we can't ship on April 30th. We have to be done earlier than that. And so, what do you do? What are your options when you're told, that's a nice looking schedule there, but that's not something that we can do? Okay, well, one thing you can do is flex the rules of the software development lifecycle model that you're following. Okay? So if you're following a V model or any other kind of waterfall model, then the rules there would be that you finish one phase before you start the next. So what you could do is say, well, instead of having the feature complete rule apply for starting system tests, because usually in a V model, you insist that all the features be done before you start the system test. You could say, well, we're going to define a core set of features that we want done before we start system test. The other features can drop in as we go along. Okay, so maybe that pulls in the end date by, say, 2 weeks, right? If we rerun the schedule, we start when we get the core build, and 2 weeks, and that pulls April 30th into April 16th, okay? So that looks good. Maybe people are happy about that, but you have to be realistic about what the price you're going to pay for that, because now you've increased the risks to quality and the project risks as well, right? What happens when you're finding bugs in the core features, because that's what you're going to start testing, core features, presumably those are the more important features. You're finding bugs in those during that 2-week period where developers are still finishing development. So what is the developer supposed to do? Finish development of the system or work on bugs? We don't want to make that classic test estimation mistake of, it's just classic testing mistake in general, of assuming that testing isn't going to find any bugs. We do find bugs, right? But it is a classic mistake. It happens a lot. So we have to think about this, that if the developers are having to fix bugs and finish the system at the same time, there's a substantial number of bugs, then that could push out the date on which the system is finished, which ultimately might slide out enough that it actually destroys any benefit that we got from starting earlier, potentially. Also have to recognize that for us as testers, we're testing against a system that's not done. We might have a higher than usual rate of test blockage, right? So that could be less efficient as well. So this is one of those things where you change one factor and that ripples through to others. So that's generally going to be true in an estimate, that when you change an assumption or factor, that's going to have consequences. Okay, so there's what it would look like if we said we're going to start 2 weeks early, and that's going to pull us in by 2 weeks. And what else could we do? Well, we could add people. We could increase the number of testers. We also have to increase the number of programmers. If you just increase the number of testers, you're going to be able to execute your tests faster, but who's going to fix the bugs? Somebody's got to fix the bugs. So maybe we double the number of testers and programmers, and we say, okay, now we can pull the data to March 26th. Assume that we're able to run the tests faster, fix the bugs faster, and parallelize a lot of tasks. They're running at the same time. But from a cost point of view, we've just doubled the cost. So people aren't likely to be happy about that. And there's also this risk that, well, maybe we can't actually hire people and ramp them up in time. Maybe bring people in, but by the time they're actually able to be productive contributors, the project's over. And this is another thing out of Fred Brooks' book, Mythical Man-Month. It's called Brooks' Law. Adding more people to a late project makes it even later. And it's based on the idea that when you bring people on, in order to ramp them up, somebody has to ramp them up. Somebody's got to train them. Well, those people who are ramping them up are people who would otherwise be doing real work on the project. So we could actually have the completely unintended side effect of delaying the project. Here's based on the assumption that we can make it work, a schedule